Yeah, thank you very much. I'm very excited to present this developing work, joint work. It's a joint work with Mike Schneider from the University of Missouri. It's very developing, so I hope the AI reporter will be merciful. So today I will try to show how we can address general philosophy of science questions using both the methods that we've been discussing over the past days in conjunction with social network analysis. I will proceed in 3 steps. First, I will present the sort of case study that inspired this work and the philosophical framing. And then I will propose, so the case study is quantum gravity, so I will propose then a bottom-up reconstruction of the landscape of quantum gravity research. And then I propose to confront this bottom-up reconstruction to the physicist's own intuition about how their field is structured. So let's talk a bit about, very little about quantum gravity, I promise. So even non-physicists, I think, know that the long-standing contemporary issue in fundamental physics is how to formulate a quantum theory of gravity. That is a theory that sort of reconciles our knowledge of small scales and our knowledge of very large scales. So there's many attempted solutions, the most prominent one being string theory. There's really a lot. I won't go through all of them. But basically, we propose, in order to account for the situation, to introduce a notion of plural pursuit. So here's the definition from Mike, who's the philosopher of the project. So we propose that plural pursuit is designate situations in which we have distinct yet concurrent instances of normal science dedicated to one common problem-solving goal. In that case, reconciling the quantum and gravitation. So generally, we have decided that each instance of normal science should be articulated by a certain community, a social community tied to an intellectual discipline matrix, and this is something that is implied or explicit in many accounts of how research programs are structured. So we want to ask something which is now an empirical question: is quantum gravity research an instance of plural pursuit? Is it composed of independent communities pursuing different paradigms in parallel? So to answer this question, what we propose first is to perform a bottom-up reconstruction of the research landscape in quantum gravity research that is not only that is of the linguistic intellectual structure of the field, but also its social structure. So for that, we gathered about 200,000 abstracts and titles of fundamental physics literature, and we proceeded then in 2 steps. So first, we performed a sort of reconstruction of the intellectual structure of the field using linguistic analysis, and for that we relied on the Bird topic pipeline that we've been talking about and we'll be talking about again. So basically, we start from the documents, we spatialize them into an embedding space, we performed unsupervised clustering on the space at a very fine-grained level. So from that, we cover 600 topics. And this is necessary because, as I will show, certain approaches in quantum gravity are really niche approaches that involve like maybe 100 papers. We have to be very fine-grained. And then finally, based on this classification, we can assign each scientist, each physicist, a specialty, which is the most common topic across their own publications. So that what it gives us is a partition of each author into topics according to this linguistic structure, intellectual structure of the field. In addition, we perform a social network analysis. So we start from a co-authorship graph, in which nodes or physicists and edges represent a co-authorship relationship between physicists. And we apply a community detection method, roughly speaking, which recovers about 800 communities from that network of 30,000 physicists. So this gives us another partition of the authors into these time communities, reflecting the social structure of the field. So now what do we mean by plural pursuit in terms of this construct, these communities and these topics? So what we mean is something like a one-to-one mapping between communities and topics, intuitively. And so, for instance, if we were to represent that in a correlation matrix between communities and topics, for instance, here we would have 3 top communities, 3 topics, and we would have something like this. So each community is entirely dedicated to one topic, and there's a clear division of labor. So that's how it would surface in a correlation matrix. If we do that, though, directly on our very fine-grained partition of the field into communities and topics, we see something that is very messy. We can see that there's a lot of structure in that thing, and it's very hard to make sense of it. The reason why it's hard to make sense of it is because I said so it's very fine-grained, and the issues with that. So first of all, the level of fine-graining of the partition into topics is somewhat arbitrary. So for instance, it could be that string theory, which is we know intuitively should appear as some sort of research program, is scattered across many topics in this classification. Additionally, we know that communities are shaped also by many different kind of micro-social processes, such that large research programs could be undertaken by several communities in parallel. All of these arguments sort of stem from a more profound issue, which is that the computational notions of topic and community are both scale dependent. We can partition literature and communities, social networks, at different scales. It's not just a technical issue, it's in fact tied to a more conceptual problem, which is that even conceptually, research programs are nested. So for instance, this is probably a bad way to do it, but we can divide string theory into families and subfamilies of research programs. So if we want to identify instances of plural pursuit, we must address this issue that there's an ambiguity in what we mean due to this ambiguity between different scales. So for that, we propose a hierarchical reconstruction of the landscape of quantum gravity research. So first of all, we build up a hierarchical clustering into topics. So we start from the fine-grained partition that we have of 600 topics, and we merge them one by one using an agglomerative clustering technique. And for the community structure, we also build up a hierarchical clustering. For that, in fact, from the get-go, we use a hierarchical stochastic block model, which learns a multi-level partition into coarser and coarser communities. So these hierarchical structures sort of induce a notion of scale, and we can decide to observe our system at different scales. So for instance, here, this is the co-authorship network of scientists. Each dot is a physicist. The color indicates their specialty, and we can observe their specialty at different level of coarse graining of the linguistic structure. And we can do the same for the community structure, okay? The problem is that the scale that we choose is still at that stage very arbitrary, and it's hard to decide which scale we should choose for one or the other structure. And we have a lot of freedom in what we choose, and depending on what we choose, this correlation matrix between communities and topics will look very different and will tell a very different story. So to select an appropriate scale, what we propose is an adaptive topics coarse-grained strategy. So the idea is that we have so these topics capture linguistic nuances and differences that may be real conceptually, but some of them have no consequences on the ability of scientists to work with each other. So what we're going to try to do is that we're going to remove degrees of freedom in this very fine-grained partition, as long as it does not remove any useful information for understanding the social structure. And so for that, we rely on a information theoretic criterion, which is the minimum description and criterion. So we're going to find a partition that minimizes this quantity, which balances the need for our partition, linguistic partition of the literature, to explain the social structure of the field. We've also the need to have as much as possible a not too complex partition, of the partition not to be too fine-grained and too complex. So if we balance those two things, what we can do is that we can, so this is our, I don't know if you can see the tree very well. This is a very complicated tree of our 600 topics, and we can zoom in as long as it improves this criterion, and then we stop when it's too much complexity with respect to how much information we gain about the social structure. And we do that, and so what you can see in color are the resulting topics. So starting from 600 topics, we end up with only 50. What I think you can see is interesting already is that certain small-scale topics, linguistic topics, are preserved by this. So they capture nuances that are important for understanding the social structure, but others are lumped together into very large topics. And so we needed to start from a very fine-grained classification, because some of these actually matters. Some of these small topics actually matter for understanding the social structure. So in the end, we end up with these 50 topics, and we can give them labels by retrieving representative n-grams, so we can understand them a bit. And we can, doesn't matter what the label says so far, and we can also restrict ourselves to those things that seem to involve quantum gravity. And in the end, we can go back to now we have these topics, which are a bit coarse-grained, and we can try to see whether they match to structures, to community structures across different scales. So for that, we'll go back to our correlation matrix, And what we can do is that for each topic, so each column is a topic, that resulting topic, we can try to identify the community that best explains this topic throughout different levels of the community structure. Sometimes it doesn't work well because topics such as this one here, the very large one in purple, seems to be something that everybody kind of cares about, and so it's not tied to a specific community. But for others, such as this one here, which in fact is string theory topic, it works quite well. It seems to be the case that string theory is corresponds to a research program that is tied to a community structure at the third level, in that case, of the hierarchy. And some research programs in quantum gravity, however, seem to correspond to communities at much lower fine-grained level of the hierarchy, is the case, for instance, of loop quantum gravity. What we can see also is that there's either not clearly a case of plural pursuit, because if you look at this community here, this small community, it's part of the larger string theory community, but it seems to be tied to another intellectual topic, which is holography. So we see that we have nested structures and we don't have a clear division of labor, and that we have different scales entangled with each other. But I don't have time to go into detail, so now I will move on to how we confronted this reconstruction to the physicist's own intuition about how this research landscape is structured. For that, we surveyed the founding members of the International Society for Quantum Gravity. We asked them to provide a list of quantum gravity approaches that come to their mind as structuring the total research landscape in quantum gravity. From their feedback, did not all agree, but we sort of built up a list of approaches that partition the field, which is the following. It's very detailed. In what follows, I will focus on the last three, which is string theory, supergravity, and holography. And the reason why is that, interestingly, some physicists disagreed about whether those should be considered separate. Some said that they're all about string theory, fundamentally, even though historically they're quite different and conceptually there's differences. So we, based on this list, so we trained a classifier to predict which papers belong to which approach using text embeddings and hand-coded labels in the training set. We can discuss later why we use this approach. And in the end, so we can predict which papers belong to which approach, and we can confront this supervised sort of top-down list of approaches to the bottom-up reconstruction. So this is it. Don't worry about it if it's confusing. The first result that we find is that, so for certain approaches works quite well. Certain approaches seems to correspond quite strongly to those topics that emerge from our analysis. However, for others, it doesn't work at all. And it seems that we can, in fact, understand why for certain topics it doesn't work, is because it doesn't work for approaches that are either phenomenological or are not really a full-fledged conceptual framework. It works very well for those that are well-defined and conceptually autonomous in a certain way. One thing I'd like to point to is that here in our bottom-up approach, we have a big string theory cluster, and it seems to encompass both supergravity and string theory. And so remember I said that physicists were not clear about whether those things should be considered separate, even though historically they're very separate. So for instance, here's a quote from one of the responses to our survey. I suppose there are a few people still interested in supergravity as a theory in its own right, but I don't think it's a large community. The overlap of people working on supergravity and string theory is so large that I'm not sure the communities can be separated in any meaningful way. And so this seems to converge with our assessment that once we strip away the linguistic nuances that have no consequences for the social structure, we find those things to be lumped together, even though they are conceptually different. And the linguistic clusters initially rightfully acknowledge this difference. So to conclude, first of all, socio-epistemic systems can be observed at multiple scales, and the notions of communities and disciplinary matrices are, it should be, scale-dependent. Identifying configurations of plural pursuit, which entail a kind of one-to-one mapping between communities and their intellectual substrate, requires matching these structures across scales. In the case of quantum gravity, a bottom-up reconstruction of the research landscape can confirm or reassess certain physicists' intuitions about how their field is structured. And finally, increasingly powerful computational methods can help us revisit or challenge philosophical insight that were for a long time intuitions. So for instance, intuitions about what is the paradigm or the community in certain situations such as quantum gravity. So to paraphrase Clausewitz, computation is the continuation of philosophy by other means. Thank you.
Thank you, Luca. This was actually perfect 15 minutes. Very nice. Are there any questions? Yeah.
Yeah, thank you. Just excellent presentation. So my question, does it work also for titles and abstracts in other languages? Let's say Chinese and German, or only English?
Only English.
Only English.
Yeah, and the reason is that I could get away with it given the distribution of languages in my database. I don't even know, but I barely encounter situations where the text is not English in Inspire HEP. Is the database, so which is basically based on Archive. Everybody publishes on Archive almost. I don't even know if Archive allows, I think, non-English papers, but I don't think it's so prevalent. So, but yeah, I was lucky that I could do that without caring about language.
Okay, Arno, next question. You want?
Yeah, thank you very much. First of all, I would love to praise you a bit because I just love your work. I love how you use these tools and algorithms in these ways when you see them. It looks super obvious, but I would have never come up with this in this way. So thank you. My question relates to how, first of all, you had this something like the optimization procedure for finding the right scale, right?
Yeah.
And did I understand correctly that you were, in a sense, prioritizing the social structure over the topical structure to do this? Or did I misunderstand this?
So it's kind of, we take the intellectual structure and we adapt it. And we adapt it in a way that basically every time there's a nuance that does not help explain, like for instance, two variants of string theory that are similar, that do not help understand which physicists collaborate with whom, because those physicists, even though they might be specialized in slightly different things, they are totally able to understand each other. So basically we want to get rid of these nuances that have no consequence for the social structure.
And no consequence meaning like, does it mean in the sense that you prioritize it theoretically speaking, that you say the social structure is so important to keep kind of, it cannot split in a certain way, that your optimizer tries to fix this? Or maybe I rephrase it. Do you use the theory somehow to make the point that the social structure cannot be split more than a certain amount or something, rather than the topical structure?
I'm not sure. I can clarify maybe what exactly it is doing. So this is based on a stochastic block model. So in a stochastic block model, the idea is that the probability that certain people are collaborating in that case or linked together is a function of their respective community. And what we propose is that we propose to assess a partition of the graph into communities according to those topics. And we try to see if it's a good explanation, it's a good community it's a good community partition of the graph, basically. And so that relies directly on this hierarchical stochastic block model.
So you're preserving the community structure.
Yeah, it's like I fix the community structure as if it was given by this linguistic structure, and I assess, is it a good community partition? How good of a community partition of the graph it is?
I guess maybe let me just finish. I think my idea is maybe you are kind of, I wonder if the arguments that you want to use, like from Kuhn and I don't know, whatever you named there, if it would suggest that also the specific way of how you measure community in terms of cooperation, right? Or citation, or what was it in your case? Cooperation?
Yeah.
That this might be too strong a theoretical assumption to make for these type of communities. That would be just my maybe you could argue people have the same paradigm or thought style without collaborating together on a direct basis. That would just be my
I think so. I think it's true. So the idea is that the notion of community is ill-defined, first of all, and social processes, they're shaped. I mean, social structure is shaped by processes which involve, first of all, intellectual similarity in a sense, but also micro processes, like, for instance, things that happen, for instance, just locally, geographically, etc. So the intuition is that hopefully if we use a rather agnostic model, we start from, we choose the coefficient graph, and so we could discuss that. The assumption is that maybe if you have a hierarchical reconstruction of the community structure, maybe microprocesses would be more would explain more the small scale features of this partition, and more intellectual dimensions would be more explanatory of larger scale features of this partition. So hopefully, that's also why we need to be able to move from one scale to the other, because depending on what you're trying to explain, one of them is more relevant. But I agree, first of all, the network, maybe the graph, the assumption that the coefficient network captures this idea of community somehow in the Kuhnian sense, for instance, maybe it's not totally right, but I think it's the best shot that we've got. I mean, if we want to go as close as possible to this intuition, we thought this is the right way to start.
Okay, I think there was another question over there.
Yeah, first of all, I want to add to the praise. It's an excellent idea, very well and clearly presented. And my question is really, wouldn't it be interesting from the historical perspective to add the time dimension here? Because you have one mapping and that aggregates a historical process, and from the way I see it, simple to have at least different time cutoffs, and then see how that mapping from the topics to the community structure changes over time, and maybe pick out the ones where it changes most. And even with respect to your last point, this the mapping to the approaches, maybe that was correct at a certain time, and this is what the people in the field remember, and it has changed. So maybe you'd even find the ideal point of time when that applied, or at least applied best. So I think it'd be very interesting to add the temporal dimension here.
Yeah, I think you're very right. At some point I thought, so sometimes when you try to reconstruct the history of languages, so you construct those trees, and the assumption is that the vertical axis tells you basically the temporal ordering of how things split up, languages split and so forth. And so I thought maybe this works for topics. I don't think it works in the case, for instance, supergravity, because it's the opposite. So basically we thought they were conceptually quite distinct, but then nobody cares now anymore about supergravity on its own, and so they merge together. And so we have interesting dynamics that challenge the simple interpretation of this thing as process of more and more conceptual sort of I don't know, division. Sometimes the opposite, and so I think it's very interesting to look at. And in the case of supergravity string theory, it's totally that. I mean, historically, I think people were interested in for maybe different reasons, but now I don't think people are interested in supergravity independent of string theory. I think it's true. So this is a very rich source of further. I agree.
Okay, there are two questions over there.
Could you go back to your last slide for a second? So you have this notion of socio-epistemic system. So my question is about the epistemic part of it. So you do the clustering on the level of the topics. And, epistemic for me means also a lot of practice. So what the scientists are actually doing. And, it's not a critique. It's something we are also struggling with. So how to get to this, actually doing, which forms also a community. And as had been rightly mentioned, also over time, it changes and gives communities the structures, or, you have some kind of collaborations or forming between communities or between scientists. So my question would be how to capture this part. So how to complement it with an approach like yours.
I don't know if I can understand the question as just one question. So maybe you can clarify, or I can try and answer anyway.
Okay.
But first of all, I mean, if we want to have this reconstruction into different intellectual substrate, our best shot is to just do this, and we take it as somewhat signal. We take it as a signal of epistemic clusters because this is our best shot. But maybe it's not true. I think in a theoretical research landscape, it might kind of work well. And then the other question, I'm not exactly sure. So, because you mentioned the temporal component, so I don't know if you want to clarify it or help me understand it.
It's just part of it. I think, if you have this, if you ask about this kind of epistemic, if you use the notion of epistemic, so epistemic covers a lot. And you have this topic clustering, and I think it's also something which changes over time. As concepts, the meanings are changing over time. The practices are changing over time, and these kind of things. And I'm just also wondering, it's not particular about your approach. You know, it's more general. So how could we cover these kind of things with large language models?
Yeah, I wish I knew. So in our case, we have this. We are lucky that, which a bit is unlucky for physicists, I guess, that the field has been, I think, quite stable for a long time because people have been struggling with their own thing for a long time. And so we have, that's why I guess it's a good landscape also for looking into this idea of plural pursuit, because we have stable sort of intellectual cluster that remains stable. People have been struggling with the same kind of basic premises for a long time. It's true, it's maybe a simplification in some sense, but there's been some transformations. For instance, the gradual shift to holography from string theorists who have shifted gradually to that, the Swampland perspective, etc. So there are changes. And we kind of collapse everything into one classification. And so I agree that we're missing some of this. But still, those temporal changes leave some imprint. So for instance, we see that there is a connection between string theory and holography in a social sense. There seems to be correlated communities. And this is because some of the string theorists have basically moved towards these holographic approaches more and more. Yeah, but it's interesting because then physicists, when you ask them to reconstruct the landscape at one point, they also, they gave you an indication. Like we have this example with the code that he struggles to answer because at some point the understanding of what was different and what is not, changes over time. So initially you thought they were different, and so there's a struggle also for the people themselves when they try to reflect about how the field is structured. It's why they disagree so much. So it's a very good point, and I don't know, and if anyone has a good answer to that. Yeah, we have to collapse everything also because it's easier and it gives us more statistical power. And some of those things, some of those topics, they involve like maybe 100 papers. It's very challenging.
Okay, there was another question. Okay, then Raphael. Yeah, go ahead.
Okay, the question. Okay, also thank you very much for the very nice talk. I was wondering, have you thought of maybe also looking at co-citation networks, like as a third way of looking at this? So the social, like the social network, and then the abstracts or the class, the embeddings, and then co-citations as a means of looking at if these communities share the same, let's say, intellectual base. So to look at, okay, do these classes also kind of overlap with the communities we see at the other two levels?
No, this is a very good point. So we haven't done it yet, even though I already wrote the code to sort of include those networks in the pipeline and look into what happens. But I think it would be very interesting to see if, yeah, for instance, we could see maybe if we use the citation network to do this, to have this adaptive clustering, maybe we get a different story. And so that would be, I don't know if it would be embarrassing or interesting, but something to look into. And then maybe we'd like to see if the citation network can sort of transcend those co-authorship network, which in a way co-authorship relationships are more demanding. It's more costly to form a co-authorship relationship. So maybe we could see something emerge out of that that we can explain based on this idea that there's a lower cost to cite and to collaborate. And maybe for this reason, citations can transcend more this linguistic structure. Yeah, I don't know, but maybe at the same time, yeah, it's complex. I mean, it's interesting to look into it and see, try to think every time of what are the microprocesses that drive these networks and in what way we expect them to be different. So yeah, don't have a good answer. Very interesting thing to look into, I think.
Okay, so the last question goes to Adrian.
Okay, thank you. And actually, perhaps you already made it clear or answered it, but I'm still not quite sure. Do you assume that the topics correlate with the communities, or can you allow for cross-community topics and cross-topic communities?
So here is an example where, I don't know if I should move. Do you see the pointer? So here, for instance, we have a community cluster at the third scale in the community hierarchy, and it corresponds to two topics, so quite loosely to this one. Oh, sorry, I let someone in, or I don't know if...
Maybe just pointed it, we can't see it.
Okay, so here we have a community cluster at the third level in the hierarchy, and it seems to be tied to this topic and this topic. And then within this community block, there's a smaller community which seems to be dedicated also to another topic. And so I think we do not assume that there's a one-to-one mapping. We are able to discover if it's the case or not. In that case, we discover it's not clear because there is a string theory community, but within this community, there's a holography community as well. And so I think it's a case that illustrates what you meant is we can assess whether it's the case. It's not assumed.
Good.